Hello everyone, welcome back. On this channel, we don't just use AI to write code. We explore how AI can understand systems. Today, I'm going to show you something I've been experimenting with. So most engineers use AI to write code. But what if AI could audit your real AWS infrastructure? Not static YAML, not mock examples, your live production setup. Today, I'll show you how I built an AI-powered AWS governance agent using Claude and Model Context Protocol. As cloud systems evolve, governance naturally degrades. Policies expand, APIs become exposed, configuration drift. The AWS console shows information, but it doesn't interpret it. It doesn't reason about risk. I wanted AI to reason about my infrastructure like a cloud architect would. So here is the solution: an AI powered AWS governance agent. This system connects Cloud directly to AWS using MCP, Model Context Protocol. Instead of asking AI to guess configuration, I let it fetch real infrastructure data via structured tools. This makes the AI grounded in reality, not speculation. So, what is MCP? MCP is essentially a protocol that allows AI models to call structured tools. Instead of prompt engineering, we give the model controlled access to systems. That changes AI from a text generator into a reasoning agent over real infrastructure. Here is the actual architecture. Claude connects to custom MCP servers. I wrote for Lambda, API Gateway, and SES, that is Simple Email Service. It also connects to AWS Labs Marketplace MCP servers for CloudFormation, IAM, and monitoring. Each layer has clear responsibility. Retrieval and reasoning are separated. AWS Labs do not provide MCP servers for some of the required services such as API Gateway and Simple Email Service. For Lambda, they do have an MCP server, but it exposes raw infrastructure, low level APIs. But raw JSON isn't intelligence. So I built custom MCP servers that abstract infrastructure into governance focused signals. This project introduces three custom MCP servers which are built using fast MCP for some of the services. These MCP servers can summarize infrastructure signals, convert raw AWS responses into structured risk indicators, improve AI reasoning reliability, and reduce hallucination risk. Now, before I jump into the demo, let me clarify something important. This was not tested on a mock system. I used my actual blog website architecture. I deliberately chose my blog website architecture because it represents a realistic serverless microservices system. It has multiple Lambda functions, event-driven fanout, messaging queues, email delivery, public APIs, so that complexity makes governance non-trivial. And that's exactly where AI becomes useful. Now let's move on to the demo. So the first step that you need to do is come into the GitHub repository. So I've put all my code in here. So you need to just clone this repository and open the code base using VS Code or any editor of your choice. So here you can see I have cloned this repo and as you can see you have some of the folders here. So the first folder that you can see here is the agent. So by the way, for this use case or for our project this time, we won't be creating any agent by ourselves. We will rather be using the Claude Desktop. However, if you have any use case or if you have any requirement where let's say you need a front end or you need some kind of personalized agent, you can absolutely do that using LangChain framework or any Pydantic AI framework or any kind of AI frameworks. And after that, you just need a front end which you can create using React or Angular or any front end framework of your choice. Although for running an agent from your end, you would need an API key because using Claude subscription and agent won't work. So let's come back to our use case. So we won't need this file anymore, so we can ignore this. So here you can see a folder called MCP Servers, and it has three subfolders: custom MCPs, marketplace MCPs, and tools. So custom MCPs are basically, like I said, that those MCPs which are not provided by AWS Labs ready-made. So I created my own custom MCP here using fast MCP. So for example, if I show you the first example, let's say AWS API Gateway MCP server, all you need is a Python file server.py. And as you can see, I'm using the Boto 3 framework. So you just create a client for your API gateway, and the rest of the procedure are very simple. You create tools. So this is how we create tools using @mcp.tool. So for details, you can go into the official website of MCP, Model Context Protocol, and also the official website of Fast MCP. So as you can see, I have created some tools called list REST APIs or get REST APIs, get resources, and there are many more. For example, get method, get stages, get deployments. So API gateway, as you might already be knowing that it's a place, it's a service that we use to integrate with our REST APIs. So for example, if I want to see what are the APIs that I have already created in that API gateway, so we can make use of these tools. So these tools are nothing but, think of it as an API provided by AWS. So these tools are actually acting as wrapper on those APIs and providing you ready-made methods which the agent can call. Then moving back to our other MCP servers, for example, for Lambda, we have another server file, server.py. Here you create a Lambda client using Boto 3, and you can have several MCP tools, for example, list Lambda functions, get Lambda functions, uh, Lambda location, and there are many more like invoke Lambda if you want to invoke a Lambda using the agent. And there are many things like event source mappings also to to get the list of the all the event source mappings for that particular Lambda. So you can do this. Then we have another custom MCP server, which is the simple email service, because in my blog, uh, I have used a simple email service, ACS service over there in order to trigger email notifications to my subscribers as well as to myself. So this is where I have created the MCP server for that ACS service. And you can see, like, we have like tools like get ACS account details, list ACS email identities, and many more. So these tools were not readily available. You just have to write your own code, own logic. Let's say you call the SDKs of the Boto 3, you call the functions, you call the APIs, and then you create a wrapper in the name of @MCP tool. So now we are done with the custom MCPs. I didn't need to write custom MCP server code for my rest of the services because those are readily available in the AWS Labs. So if I show you the AWS Labs, so this is the official website of AWS Labs, awslabs.github.io/mcp. Here you can find a list of all MCP servers that they are providing as of now. For example, I needed Amazon SNS SQS MCP server. So if you select this, you can find the configuration that you need to use, and this is what the agent will be requiring to call this particular MCP server. And then there are other things like, like what are the troubleshooting steps and all. So you won't be needing that as of now. And there are other MCP servers as well. For example, uh, I needed to use CloudFormation MCP server, so it gives you all the features. So these features actually can behave as tools as well. So if you go to the tools section, you can see what are the tools like create resource, get resource, list resources, any particular schema information for a particular resource. So all these are ready-made tools. Tools are nothing but kind of a method or a function for that particular service. So in this case, it is CloudFormation service. So likewise, you have a lot of other MCP servers. So and as I said, like for Lambda, they do provide MCP server, but they provide you low-level APIs. So I had to prepare my own custom MCP server for that. And you have other MCP servers, for example, there is a one for CloudWatch, and for AI machine learning also there are a lot of MCP servers. I have used DynamoDB database in my blog website architecture. So there is an MCP server regarding that as well. So if I go here, if I go to the data and analytics tab, here you can find Amazon DynamoDB MCP server. So here you can find the example tools that they provide, as well as the configuration JSON file. So now if we move back to our code, so if I open this folder, you can find several JSON files. These are nothing but those uh, configuration settings that I have copied from there, and I have created individual JSON files here. So for example, for CloudFormation, this is the configuration for MCP servers. Then CloudWatch, DynamoDB, IAM, and like that. And also, since I have put my blog website code into GitHub, so I can also use GitHub MCP server. So what the agent will do, if for example, if I give a query like get me the code base, or find if any vulnerabilities are there in my code, in any of the lines of code. So any kind of query, if you want to write to the agent, what the agent will do, the agent will call the GitHub MCP, and it will try to figure out which repository I'm talking about, and which piece of code or which file am I talking about. So this is the settings of the GitHub MCP. You can find this in the official GitHub MCP server repo. So if I scroll little down, you can find the details over here. So you can just copy and paste it over there. As a next step, you need to find the Claude Desktop configuration file. So if you come into this location, Claude, you can find this desktop configuration file over here. All you need to do is double click this, and then so initially the the Claude configuration file won't have any MCP servers. If you haven't used any MCP server before, so it will only have the preferences object, and all you need to do is create an object called MCP server and add all your settings individually one by one below one another. So what I did, I first added the configurations of all my custom MCP servers. So I have given the path of my server.py file, and in order for this Cloud Desktop to get access to this MCP server, so you need to run these MCP servers individually. I'll 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 get back to that point. But you can see, like, we have added the configuration for individual MCP servers, and then after all these three custom MCP servers, I have added the configuration for the AWS Labs provided MCP servers, for example, for the CloudFormation, for the CloudWatch, DynamoDB, IAM MCP, anything. So you can directly get these things from the AWS Labs MCP server official website. That is this one. So now as we have saved this, all you need to do is restart your Claude Desktop. But before that, as I said, you need to first make sure that you are running these servers. So you open a terminal, go to this path server.py and just run python space server.py. Similarly, you need to do for the other two custom MCP servers also. So as you can see, I have opened three terminals here. I am executing this command python server.py for each of these MCP servers. So for ACS, my server is running. For Lambda, my server is running. And for the API gateway, also my server is running. Now you need to just restart Claude. If you open Claude, so this is the chat interface that you guys have already been looking into. But before that, I also wanted to let you guys know that I have also used the MCP server of AWS well architected framework. Why? Because I would need to know whether my architecture is abide or aligning with the well architected framework rules and guidelines or not. So now we are done. Let's open the Claude Desktop. So what you need to do before you start chatting, you need to verify whether the connection from Claude Desktop to the MCP servers are being made properly or not. Are they working properly or not? So you need to go to Claude and you need to go to settings. And here, if you go to connectors, you would see that all my MCP servers are connected automatically. So now let me go back to my chat screen and try asking something regarding my Lambda function. What all Lambda functions have I used? So the agent is trying to list my Lambda functions. As you can see, it has successfully connected to my Lambda MCP and it has given me all these function names. So yes, these are the functions that I have created in my Lambda. Let's say if I say yes, if I continue the conversation, yes, I would like to know about blog get likes. It is asking your permission to allow whether it can connect to Lambda or not. You you select always allow. So as you can see, it is getting the entire information of that particular function, the ARN number, how much memory it is consuming, what is the timeout, what is the code size, everything. Agent to analyze my architecture and let me know that whether it is production ready for 1 million users or not, whether it is scalable or not. Let me press enter. So as you can see, it has checked the Lambda integration. It is also trying to check the API gateway and the other things. It is now trying to analyze the Lambda role risk, whether IAM roles are given properly or not. Now it is trying to list the REST APIs that I might have used in the API gateway. I'll pause the video and once all the analyses are done, I'll resume the video and show it what it has shown me. Okay, so my Claude has successfully analyzed my entire architecture and as you can see it has the comprehensive picture of my entire architecture and it is giving me the summary. For example, it is saying that I have an API gateway, which is true, I do have an API called personal blog API, and these are the APIs that I have used. These are the routes that I have used. I have four Lambda functions, and this is the ACS details, and this is where I am deploying my front end. And it is also giving me the risks associated. For example, it is giving me a verdict that my blog website is not production ready for 1 million users. And there are some high severity risks because I had disabled some security functions just to showcase this demo to you guys. So there are some high severity risks. For example, no API gateway throttling or rate limiting. I haven't done that. Then there is no WAF protection, and four API routes have zero authorization, etc. And so many other things. And there are some medium severities, for example, no dead letter queue, no API access login, no usage plan, nothing. And there are some low severity issues as well. For example, this architecture. So the functions are on 8664 architecture. So it is suggesting me to migrate to ARM64, which is Graviton 2, which will reduce my cost by 20%. So as you can see, it is also giving you recommendation based on your cost, your analysis, your usage, and it is suggesting you how you can reduce your cost as well. And it is also giving you some positive feedback like, yeah, your ACS is out of sandbox or course is already implemented, and it is giving you some priority action plan like what are the actions that you need to execute immediately, then before scale, and what you need to do ongoing. And yeah, so as you can see, this worked. So your Claude Desktop can connect to individual MCP servers, and it can do a governance of your entire AWS architecture. So it is actually behaving an AI intelligent architect. Let me close with this. AI shouldn't just write code. It should understand systems. What you saw today wasn't just Claude calling AWS APIs. It was an AI reasoning over live infrastructure, evaluating governance posture, and identifying architectural risks. And this is just the beginning. The same foundation can evolve into CI/CD governance gates, infrastructure pull request reviewers, drift detection agents, and even AI-powered platform engineering copilots. We are moving from prompt engineering to infrastructure intelligence. If you found this valuable, you can explore the full write-up on my blog, check out the source code on GitHub, and subscribe to the newsletter for deeper dives into agentic AI, cloud architecture, and system design. And of course, if you enjoyed the video, like and subscribe. It really helps. See you in the next one.